Coming up.
3, 2, 1.
And an Atlas V 401 launches TDRS.
And Master Space System Zombie learns to think for itself.
All that and a whole lot more on this January 25th episode of Spacevidcast Live. Let's do it! Welcome to Spacevidcast Live. My name is Benjamin Higginbotham. With me, as always, the beautiful, lovely, wonderful, and talented Carrie Ann Higginbotham. We're joining you this Saturday, January 25th, 2014, for episode 2 of season 7. Now, before we get into space news, I did want to take a quick moment. We talked about it a little bit last week, kind of in the middle part of the show, and I want to do it up front in this part of the show, and I want to talk to you about the program we're working on right now called Patreon. It's pretty freaking awesome. Patreon is a lot like Kickstarter, but for podcasts. It's like a recurring Kickstarter. So this is kind of the general page. If you go to patreon.com/spacevidcast, this is the page you're going to see, and you'll see on there you're able to pledge. And then you can pledge any amount you want, kind of like Kickstarter. So if you pledge, go ahead and go to the next graphic. If you pledge like $1 or up to $5, there are different rewards that you're going to get for different levels. Unlike Kickstarter, where you pledge once, you pay once, and then you get something, and you're done with that campaign. Patreon's kind of more for artists, where you're creating recurring content. So you pledge and you say, okay, every time Spacevidcast releases a show, I'll give you $1, or I'll give you $5, or whatever that amount may be. I'll give you 50 cents, right? You pick the amount. So every time we release a show, you pay that amount. But there is actually a safety precaution to make sure that you're not charged an arm and a leg. You can set a maximum amount that you're going to spend per month. So if we release 20 shows and you had pledged $10, you're not going to get charged $200 if you said I have a maximum of like $50 or $20 or whatever it may be. And Spacevidcast isn't the only entity out there that's doing this. There are a lot of really cool Patreon campaigns going on right now, and I encourage you to take a peek at them. One of our rewards inside of Patreon is that for anyone who pledges under $5, you become, from $1 to $5, you become a Spacevidcast patron, and we will roll this into the kind of the middle part of the show, make it part of one of our graphics. But these are the people in the last week, without us pushing it really hard, but these are the people who said, yes, we think Spacevidcast is awesome, we're going to give you at least $1 to make these shows happen. And keep in mind, that's like less than a cup of coffee, right? I mean,
right.
It's less, even if you consider 4 live shows per month, that's less than...
It's still less than a cup of coffee.
A cup of, like a really good cup of coffee, or like a mocha from Starbucks or something like that. And every dollar helps. It helps us a great deal, and it adds up very quickly. And we're getting, already within 1 week, we're getting very close to, not quite break even, but at least being able to pay for the Amazon S3 and web hosting that we have to go, the monthly recurring charges for that. Now, for those who pledge $5 and more, you actually become a Spacevidcast producer. You get a few more perks. These are the people who have pledged that amount, and a huge thank you to everyone on this list for making that happen. It means a lot to us that you would spend your hard-earned money on this show to make it keep going. So I know everyone hates when we spend time upside in space in front of the Space News segment to do things like this, but it is important to keep the show going, and I hope that you guys like the show enough to pledge even just a little bit. Any 50 cents, $1 per show, 25 cents per show, $5 per show if you can afford it, whatever you're willing to give. It's a lot like Epic, except that you get to set the price. Whatever you think this show is worth, that's what you should pledge for it. You can, of course, cancel at any time, and you can set those upper limits so it's fair to you. And the guys over at Patreon, they're pretty awesome. They're really cool guys. We like them a lot. So let's go ahead and get into space news. China's moon rover is having some issues. We've actually got some footage. This was the footage they have of when they were approaching the moon. This isn't the rover itself. This is the landing craft, but I thought it was really, really pretty, so I figured we'd actually just show it. There's a mechanical control anomaly, and there's not a whole lot of information on it, but the basic assumption is that the mechanical control anomaly is due to the, quote, complicated lunar surface environment, unquote.
Which is kind of hilarious all the way around. I mean, you would think this is something that should be tested or has been tested. We're all familiar with regolith and...
regolith is nasty stuff. That's, for those who don't
nasty.
know, that is the kind of that what you're looking at right now, that kind of gray surface of the moon. It's a fine dust. It's a lot like sand, but sand has, over millions and millions and millions of years, been softened and kind of polished down into these fine, soft grains. Regolith hasn't had that happen. So it's like sand, but really sharp. And it
really
gets
sharp. And it gets everywhere.
everything, right? It gets in your joints and your seals and your motors and all of it, and just rips all your gear to shreds. It's one of the really hard things about going to the moon. It's just dealing with regolith. So this happened before the rover entered its second dormancy stage at dawn today, actually, as lunar night is falling. One lunar night is about 14 Earth days, or as I almost said, 13 Earth days.
Went a little Swedish chef there for a second.
Yeah, I
Sorry.
did a little bit. And for those who don't know, the probe itself actually landed, I think that was December 14th of last year, of 2013, to make that go. Some other space news: an Atlas V in I think it was I didn't write it in my notes, but I believe it was a 401 configuration, has launched the TDRS.
4, 3, 2, 1. Main engine ignition and liftoff of the Atlas V with TDRS-L, building our ability to meet the growing future of communications in space.
Booster view has gone to closed loop control. Pitch yaw roll program has begun. Vehicle body rates look good. Most battery voltages are stable. Tank pressures are as well.
So what I didn't get to say, TDRS is NASA's tracking and data relay satellite system. So actually, fun little factoid: if the acronym is TDRS, that stands for an individual satellite like this. TDRS-L, which was launched, would be TDRS-L. But if it's referred to as TDRSS, that's the entire constellation, it's the entire system. So, yeah, I know, fun little thing that now you've learned if you didn't know before. This is the ability for NASA to send their signals up instead of down. If you remember in the Apollo era, or maybe you don't because 50% of the planet wasn't even alive, but in the Apollo era, when they were coming back for re-entry, all the radios pointed down, and as they were coming in, all the atmospheric re-entry, that plasma that would happen on the bottom of the vehicle basically prevented the radio signals from making it down. So we lost communication for several minutes. Well, now what we do is instead of going down, we have radios that point up, and they hit the TDRS satellite communication network. And this communication network goes all the way around the Earth. And so no matter where the vehicle is, you can send your signals up, bounce it all the way back around to wherever you're going, for example, Houston, and then send it back down. So even as you're re-entering, you still have communication. You can use it for the International Space Station, so we never lose communication with the space station when it's, say, over the ocean with no ground station coverage. You can use it for many different things. And this is a next generation TDRS satellite that should give them faster speeds so they can do more things like high definition downloads and stuff like that. So that was how United Launch Alliance Atlas V rocket that launched January 24th of this year at 02:33 coordinated time. You want to take the next one?
Yeah, absolutely. So Morpheus has had its third free flight, which is really exciting. Which is on January 16th. I apologize that we didn't actually have this in last week's show. But
we were slackers.
Apparently. But it was at the north end of the Space Shuttle Landing Facility at NASA's Kennedy Space Center.
I thought they were testing in Texas.
I thought so too, but I don't know. The thing is that when Morpheus lit, it actually lit underneath on top of a flame trench. And so I'm wondering if maybe that something like that wasn't available where they were in Texas, and that's why they moved over to Florida.
Could be. It was Texas, though, right? I'm not crazy.
Absolutely. When you go for more information, you actually go to the Johnson Space Center.
Oh, all right. Yeah, okay.
Yeah, so,
right.
But for some reason, this one at Kennedy, what have you, it's all right. It ascended about 187 feet in the air, translated for over about 154 feet, and then landed within 11 inches of its target.
And we actually have some footage. It's actually quite beautiful. Check it out.
4, 3, 2, 1.
Otherwise, strictly second. Wait 15 seconds. Wait 10 seconds. Good control.
That's just awesome.
It's gorgeous.
I love that right there. Boom! Picture perfect.
Beautiful.
Shut down.
Yeah.
Really
Ab-
solid. So went up 187 feet, over, or translated 154 feet, came down and landed within a foot of its target, which is really great. So Project Morpheus, just in case you need a refresher, is testing NASA's automated landing and hazard avoidance technology.
And this is important for things like when we're going to Mars and we're landing, we need to make sure that we don't let, using Apollo 11 as an example, Neil Armstrong had to take manual control of the lunar lander
Right.
so that they could avoid some huge boulders that were in their way. Well, this is an autonomous way of essentially doing the same thing.
Yeah.
That's one of the applications, one of the many different applications.
Yep.
So speaking of Dave Maston in 2009, Maston Space System... Maston Space Systems G-fold diversion test. So we've got a cool animation. So this is a Google Earth animation showing...
Wow. Showing the flight pattern.
Showing the flight pattern. So what happens is they launch the vehicle, Zombie or Zoe, one of their X vehicles, up, and then they issue a divert command instead of landing. So then you can actually see it has the diversion, and then it actually goes to a brand new landing site, and the vehicle's calculating all of that in real time. Here's what that looks like on the vehicle itself. Check it out. I love the engine cutoff noise.
So, particularly with these two videos back to back, they're going to look like they're basically the same kinds of thing. And the thing that you need to understand is that the Maston flight with the G-fold diversion test, this is all about the computer making decisions on its own. The engineers knew that there was going to be this abort test, if you will, but the computer didn't. So mid-flight, it got the, oh my goodness, you can't land right where you were supposed to go, figure it out. And on the fly, it made decisions, figured out a new landing site, made like the most, eloquent way of getting to the next landing site, all by itself, all in real time, all mid-flight, and it also landed within 9 inches of its new target, which is really incredible. So that's kind of the difference between those two. One is, mostly for cargo, and the other one is demonstrating the flight system kind of becoming autonomous and thinking on its own, if you will. And it had no warning. It wasn't a practice flight. The computer itself thought that everything was going to be normal. It was just going to go up, come back down, everything's cool. And all the way up, the engineers are like, just kidding, you guys. And it had to figure it out on its own. And it did beautifully. This actually was September 20th, 2013. But we are just now getting the video of it. It ended up to be about a half-mile diversion, but it was a planned. The engineers, like I said, it was a planned abort.
I love watching the engine kick.
Yeah,
It figures out the diversion and the engine's kick. It's like, this way now.
Absolutely.
It's fun. Yeah.
It was really cool. Max altitude was 1,200 feet. It translated about a half mile, or went over about a half mile, at about 50 miles an hour, which is pretty fast, I would imagine. And then, like I said, landed within 9 inches of its new target, which is really incredible. So
Congrats to Maston Space Systems. That's really awesome.
They've been working with Jet Propulsion Laboratory on that.
All right, let's take a quick break, and when we come back, the main topic, which is destinations versus infrastructure. Stay with us. We'll be right back.
1, 0. Liftoff.
The fleet of space shuttles were doing amazing things in space.
We've got all your space geekery right here.
And welcome back to episode 7.02. We had a really interesting comment from, See,
Maya.
this is what happens when I'm not paying attention to the technology on the desk. From Maya K on our last show, and I was thinking about it. I'm like, actually, this is something that will require a little bit more talk than the 30 seconds we're going to give it in the comment section of the show.
Right.
And that is, in last week's show, at about 30 minutes in, we talk about destinations. In my opinion, we need to focus on improving the space transportation infrastructure itself. We cannot move enough mass fast enough in transit, and we cannot lift enough mass into low Earth orbit in an economically and sound manner. So, there are two ways to look at this, and that is one of them, right? Which is
Sure.
you don't have the infrastructure, so you can't go anywhere.
Right.
But the other way to look at it is, where are you going?
Right.
So, are we going to Mars? Because that's very different than going to the moon. So do you pick a destination and then build the infrastructure for that destination? Or do you do kind of like the U.S. highways, which is where you just kind of have them going across the country, just kind of say, okay, well, these all go across different areas. Now build offshoots of those to wherever you need to go.
Interesting.
Right.
Interesting.
Oh, what's your opinion? Where should we go?
Well, I don't know. My worry about, kind of like you said, not picking a destination and just working on the infrastructure first is that we'll just sort of, it'll inhibit us, oddly enough. I think what will end up happening is that we'll be working on this and everybody wants, say, warp drive. And so we're not going anywhere, you guys, until we get warp drive, because otherwise, we're not going to get anywhere. Do you see what I'm saying?
That makes sense. So then, where do you draw the line,
confusion.
right? Because that's a valid point. Because you could say, okay, well, yeah, I mean, we could build the infrastructure to get to Mars. Oh, but I mean, you're not going to go much further than that.
Right.
You're not going to be able to send humans at least much further than that.
Right.
So then, do we just say, okay, well, that's not very far. That's not very good. Do we wait till warp drive?
Right.
Or do we put all of our efforts into designing something that may be potentially impossible? And then forever delay absolutely everything.
Right.
So this is the reason this is an interesting question is because that's what we view the problem with the Space Launch System to be. For those who don't know, the SLS program, Space Launch System, is NASA's next generation rocket. It can bring a boatload of payload into space. It is also very expensive. It's very expensive to design, very expensive to build, and very, very expensive to fly. And so you look at this rocket and you go, okay, great. So we're designing this huge, huge rocket. Where's it going?
Right.
What is it? Are we going to the moon? Are we going to?
I don't know. It's going. Okay.
It can go up. And then what? And so that's why I thought this was an interesting question, because I had always viewed that as like, obviously this is wrong.
Right.
You need to have a destination in mind because space is hard. Right, you can't just go, oh, I'm going to build a rocket, I'm going to go to Mars. No. Right? You look at what SpaceX and Maston Space Systems and some of those other guys are doing, and it's clear, definitive steps on, we need to figure out these things in order to get to Mars.
Right.
These things that they're figuring out don't necessarily get them to the moon. Some of them will help them get to the moon.
Sure.
But, a lot of them are specific to Mars. So if you don't have a destination in mind, are you able to still make a program that works. So I guess the difference is, do you take the Mastin/SpaceX approach and go destination first, or do you take the NASA approach? It's not really NASA, it's more congressmen. Do you take the Congress approach and say, nope, build the big rocket, and once we have it, we'll figure out where we want to go?
Yeah, I mean, I don't know. Like I said, I mean, my initial reaction was sort of as if you had said, I'm going to surprise you for our anniversary. We're going on vacation. And I'm saying, okay, well, I need to pack. What am I packing for? And you're like, you're packing for vacation. Great. Do I need a parka and skis, or do I need like a bathing suit?
Vacation.
Right? And that's not really an answer, which is kind of unfortunate. And so, so then at that point, do you pack for everything? Do you make a vehicle that can go anywhere and everywhere? And then at the same time, do you wait until that vehicle is done that can go anywhere and everywhere? Like, do you wait for that warp drive to even take the baby steps outside of low Earth orbit?
So 1/Alpha in the chat room says, once you're in orbit, you're halfway to anywhere. So you just need to get out of Earth's gravitational well and then get to wherever you need to get.
Sure, but that other halfway is relative.
Why? Because generally when you get into orbit, you're out of fuel. You're done. Your rocket is spent. So you're halfway to anywhere, but you're stuck halfway there.
Right. I mean, then I guess that's a time versus quote unquote fuel issue. Eventually I'm going to make it to Pluto, but I'll be dead by the time I get there. That's the other halfway versus, the halfway to Mars at that point.
Sure.
You see what I'm saying? Like that other half is relative. And so I don't know. I'm not saying that I have the answers to that, but that's my initial reaction is I don't want to wait till we have warp drive to get anywhere.
But maybe it doesn't need to be warp drive. So maybe it's a combination of both. Maybe it's saying, look, we're going to Mars, which means we need some infrastructure up there.
Right.
We need a fuel depot that's not at the International Space Station's inclination, one that's at a reasonable inclination that will help us get to Mars or the Moon. And we need to make that so that you can go up, you dock with this fuel depot, you refuel. At that point, you're halfway to anywhere,
right? And
now you can get the other halfway there. Maybe that's a requirement, as opposed to doing the von Braunian style of just build a really big rocket. The chat room is really talking about Nautilus X, which is just basically a really big space rocket.
Right.
It's a huge, just huge space-based rocket, I guess is the way to say that, and it would be awesome. It would be really, really cool, but we don't have the things necessary today to make all of that happen. So that's, I guess, that's the topic. That's what we'd like. We don't have an answer.
We don't.
Sometimes we're like, yeah, let's talk this through, figure it out, and isn't that interesting? Well, I don't know what the real answer is. And another great question was brought up in the chat room. Someone asked, I wish I could find it.
Okay.
Oh, Jim Nobles, he asked, who's going to pay for the Space Launch System payloads? So, now you've got this really big, huge rocket.
Right.
Who's going to pay to actually launch it?
Yeah.
Because it's so... I mean, we're talking billion or billions per launch plus payload. Who's going to pay for that?
Maybe we're going to lend it out to other governments.
Doubtful, not with ITAR.
Yeah, I don't know. And that's the other sort of side of it is like, okay, well, now we've got this now we have this great big rocket and nowhere to put it to. Where do you want to go, guys? I haven't really thought about that. It's a debate that needs to go sort of
NASA. That's actually another part of this debate is so it's not just infrastructure versus everything else. It's, we've asked this question before, but should NASA be in the rocket business? Does NASA need to build a rocket, or can look at SpaceX? Falcon Heavy's coming out sometime in the future. That's going to be an impressive rocket. Why not let a company like why not let Boeing or Lockheed build another giant rocket on their own dime?
Yeah,
right?
ULA is doing just fine all by themselves.
Don't make the government pay for it. If one of these companies wants to do it, let them design and build it. Do it commercially, completely commercially. NASA, you can't poke your fingers in there and say, well, you need to support this, and that. No. They'll come back to you and say, this is what the capabilities of this rocket are. It is human rated to this level. What do you want to use it for? Obviously, there would be trade stuff. Maybe that's what we should do. I have no idea. Anyhow, love your comments. Leave them in the chat room. Leave them in the YouTube chat room. What do you think? Should NASA be building rockets? If not, what should they be doing? should we actually be saying, look, just build really giant rockets and we'll figure out where they're going to go later? Or should we say, no, we're going to Mars, let's build rockets specifically for going to Mars, and then once we're on Mars, figure out how to get somewhere else? Or the moon. And is that economical? Because can you use the same infrastructure that you're using to go to Mars to go to the moon? Maybe, maybe not. So how does all of that work?
Interesting.
Love to know what you think. Leave them in the YouTube comments. Leave them on spacevidcast.com. And speaking of comments, we're going to take a quick break. And when we come back, comments from last week's show. Stay with us. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
Welcome back to episode 702. Comments from last week's show. Last week it was the first time back since middle of 2013.
Got a lot of comments in my hair, thanks. Appreciate that.
Really?
No,
Did you?
I'm just kidding.
Well, now this time you will. You're
will
going to get
now.
a ton of
Yeah.
comments on your hair. There were quite a few comments regarding to the space news that we talked about. And the first one comes from Greg. He says, we need a new International Space Station in a Lagrange location. The ISS does provide a great science platform and would be even more useful in an L2 orbit. The Bigelow modules would be great. So the Bigelow modules are giant inflatable space stations, so you can get essentially the same volume in one of these Bigelow stations as you have for all of the ISS, which was assembled in space. That would be kind of cool. Lagrange points are the kind of a special point in between two celestial bodies where the gravity pulling on each kind of holds it in for the most part, holds it in place. So you don't need a whole lot of fuel to maintain that particular orbit. So you could use it as a launching depot, right? So you can launch stuff up there, use it as a fuel depot. It doesn't have to expend its fuel to stay there, and then use that as a platform to get somewhere else. The issue, of course, we mentioned a little bit earlier in the show, the International Space Station's at an inclination that is perfect for both the U.S. and Russia to launch to it and to control it, and that's about it. It's at a really bad inclination if you want to go to the moon or go to Mars. It would be technically possible, but you look at it and you go, why? So, point is we should have a new International Space Station at a Lagrange location. Interesting concept. Or take the current ISS and move it. I'm not sure.
Can we get it there?
Magic thrusters.
Okay.
So, magic pixie fairy dust.
Right.
Somehow, someone takes huge engines, maybe leftover shuttle engines, and boosts it. That wouldn't work. Whatever. Into a different... Magic. Yes, it's probably possible.
Okay.
Do you want to? There's a lot of cost associated with that, but it is like $100 billion structure. I mean, it is one of the most the most expensive structure humans have ever built.
Sure, but then it's also getting astronauts to and from there. I mean, there's all of that fun stuff.
That's true too.
I mean, this isn't gravity. You're not just gonna throw in another jetpack and then fly home.
Actually, I didn't realize I had done this. The next comment from Fabio, which is just fun to say, Fabio. Says the International Space Station is very relevant. It would be much more cost-effective to use the ISS as a spaceport to dock there with all the spaceships you're going to need for deep space exploration. Ships that will never land on Earth but ferry astronauts around the solar system. So basically cyclers that go, they're built in space, made for only space.
Right.
They could not withstand re-entry into an atmosphere, which means you could make them larger, right?
Yeah.
I mean, you can make them for
Larger,
the specific
lighter.
task.
I mean, there's so many different...
Yeah, so, but you would use the ISS as a launching post for that. Again, wrong inclination, we need to move it. But interesting concept. And this goes back to us saying, well, what are the science experiments on the ISS? Is it still worth the very high cost of running the ISS? I think the answer is yes. I just think that we need to better educate ourselves. Maybe NASA's doing this, maybe they aren't, but need to better educate ourselves on what actually is going on in the ISS so that we can go, oh, no, that does make sense.
Right.
That is worth doing, absolutely. Bill Hughesley says, it, referring to the Space Launch System, will fly just like Ares flew.
Ouch. Ba-dum-bum.
Ares kind of... Ares
Lit?
sort of flew? Well, there was the Ares 1X, which
Right.
wasn't an Ares. It wasn't the same first stage. It was a dummy second stage. It wasn't the correct avionics, but it was the Ares parachutes.
Yes.
So there were those. The real parachutes were on board.
Tribal electrification.
So, yeah, I think the concept there being either one of two things. One, it will never fly. It will never make it out of paper rocket stage.
Right.
Or two, if it does fly, it won't actually be the Ares rocket. It will be kind of a dummy system that they've designed to simulate what they think it might be like, but not actually build the real thing, just for purely politics. We'll find out. NASA they've got money for it. I mean, they keep,
Right.
the Congress keeps diverting funds into them for SLS, so we'll see. I'm not sure. Nightlight ABCD.
That's a good name.
That's an interesting
It
name.
took me a minute.
Says, there is no way that a manned flight to Mars would pass a cost versus benefit evaluation. The manned flight to Mars and the possible manned flight base is more of a jobs program, and the greatest benefit would be for the contractors. We are already on Mars. We have satellites and rovers on Mars right now, and much, much less cost. When considering the cost of the International Space Station, one also needs to add in the cost of Space Shuttle as well, which was not inexpensive. Space Shuttle was billion plus per shuttle and $500 million plus per launch.
Right.
I mean, that was very expensive to launch the Space Shuttle as well. So this goes back to the concept of humans or robots. What makes more sense? I know we've had this discussion on Spacevidcast before, and I think the answer is both.
Yes.
The amount of science done on Mars by robots is awesome, and we've done it, and we've got a presence right now on Mars.
Very cool.
Nightlight ABCD is absolutely correct. We have rovers actively on Mars right now. It's very cool.
Very cool.
And the amount of science that they have done could be done by one human since every rover has been there.
Mm-hmm.
One human could do more science. I think it was a week, but I'm going to say a month.
Sure.
In 1 month on Mars, one human could do more than all of that technology combined. Yeah. So that's the difference. Now, rovers and robots are getting smarter as mast and space systems. I'm sure their rovers will come to life soon. We do hear bow to our robot overlords on Spacevidcast.
Was that a joke because we just showed a zombie?
Yeah.
Okay.
Mm-hmm.
I got it now.
It was a little subtle, a little too subtle, but
Go
yeah.
on.
So I know these vehicles are getting smarter, but at the same time, there's nothing quite like having a human brain and body there to do stuff. It will be difficult because you'll have to be protected from the lack of pressure, the atmosphere. It's not like just walking outside and picking up a rock, but it will still be way faster and better. So I don't think the answer is one or the other. You don't want to just send humans to a celestial body without having done some robotic scout missions before. But at the same time, the robots can't do what humans can do. So we should, in fact, do both. And it's just, then people argue over funds. Well, should you put funds here or put funds there? You should, in my opinion, fund both. There's no reason you couldn't. If we took the money that we spent on war and funded it on advancing the human species, imagine where we would be. It's a choice to not fund both, or choice to fund one or the other. And that's a choice that, depending upon where you are, if you're an American, it's a choice that every American makes through their elected officials. And if you don't like the choices your elected officials are making, do not re-elect them. And if you, convey that message to everyone else and make sure that they agree with you. Was that a little too soapboxy?
No.
I did soapbox a little bit there. I'm sorry,
but a little bit.
Oh, this one's long. All right, so I have the full question here. You guys are just getting a part of the question, so here you go. This was an email sent to us by a journalist, and the entire email goes, I'm a journalist writing for an online platform. I'm currently working on an article about the way Mars One intends to broadcast the mission to the public. I would like to know how the space community, I do not know why that's in quotes, and the scientific world look upon the media spectacle this mission is turning out to be. Therefore, I'd like to ask you a few short questions in your broadcast from May the 5th last year. You discussed this project and called it a reality show. Would that necessarily be a negative thing? Or could you also do a great way to support the general public more interested in also a great way to make the general public more interested in the public. Nah, that's how he wrote it. All right, whatever. Basically, is it a way to get the general public more interested? You also stated that you would support the idea of a Mars missions, but you want to do it done the right way. Will the reality show aspect get in the way of actual scientific progress? Are the participants actually able enough since they are eventually chosen by the public? Enlighten me on this. So, basically, what's wrong with Mars 1? Will it be the worst thing that happens to space or the best thing that happens to space?
That's one way of looking at those
The
questions.
reason we added this in viewer comments is go ahead and add your comments. So we'll answer what we think live on the air, but it's all speculation at this point.
Right.
So, there are a lot of different members of the space community, and a lot of us have different opinions.
Mm-hmm.
I'm of the opinion that all ships rise with the tide, and that any talk about space, no matter how insane it may sound on the surface, is good talk. And an idea is only crazy until it succeeds.
Right.
Right? 10 years ago, SpaceX was crazy. Not anymore.
Right.
Right? 10 years ago, Mass and Space Systems was crazy. Still a little crazy. But getting less crazy. Dave's he's just a little evil scientist. He's got just a little evil overlord in him.
Can't wait
Just
for him to watch this show, because he's hiking right now, so he's not watching it live.
That's why I can say all this.
Right. Well, and if I can, I want to focus on will the reality show aspect get in the way of the actual scientific process, and are the participants going to be able enough if they're chosen by the public? The original astronauts that we just threw out over to the moon, while they were fighter pilots, they didn't know how to be astronauts. That wasn't something that they inherently knew and understood. So anyone who's chosen by the public, and I kind of get a feeling it's a little bit rigged, but we'll ignore that for a moment. But anyone who's chosen by the public will say they're going to get training. It's not like we're just going to pick out the next iJustine because she's adorable and really great on camera, and then throw her out to Mars and hope everything's okay.
She would die.
Just saying. And then
anyone would. I'm not saying it's her. I'm saying anyone who was just thrown to Mars without any training would most likely die.
I'm not really worried about that. And it would also seem to me that the process should be fair enough that if during the training, if somebody goes, you know what, I'm out, that they're going to let the person go, and so there's all that. So I'm not even worried about that part of it necessarily. The other part of will the reality show aspect get in the way of the actual scientific process? I think this is something that we have addressed before on the show, and it could be, depending on how they want to do the show, it very well could be a hindrance in my mind, because their reality shows typically are looking for all of that drama. They're looking for, oh my God, and Jamie totally was hitting on Barbara, but Barbara totally likes Joan. Don't tell anyone. And there's all of that kind of stuff that goes on.
On camera.
Right, exactly. That people are looking for, because they're looking for ratings. And, mold growing for the 7th day in a row is not going to bring in the same kind of ratings as Barbara really being in love with Joan. Okay, it's just not going to happen.
But why does it all have to be science? Why can't we just...
It doesn't all have to be science. But is the reality show aspect going to interfere with the scientific process? Not the scientific process, but of the show itself. I guess it could get in the way. It could be, if a producer starts going, I don't know, you got to make sure you're hitting on her every single day so we get some ratings.
I'm not convinced that we need to have science on Mars 1 at all. Right? So let's just put humans on Mars. Let's just get humans on Mars. Let's create a backup to humanity.
Sure,
let's get that process started.
Just getting them there and then being like, I don't know, guys, chill, is not going to be interesting.
No, but so all right, let's just play that out for a moment. So we get them there, right? And now that we've got this live broadcast, and they do their drama-filled reality show, and it's all whatever it is. But guess what we've done? We've created a transportation system that can get humans to Mars.
Yeah, that part I'm interested in.
Great. So reality show. But now we can do other things too. We've actually done it as humanity. Now we need to figure out how to replicate it and keep it going and never let it stop. Don't let it turn into the next Apollo.
Right.
So it could be a good thing, even if there's zero science on the show, even if there's zero advancement anywhere else. Yeah. It puts humans on Mars, assuming it works.
Sure.
I think they woefully underestimate what it will take to get humans on Mars. There are exactly 0 craft on Earth capable of doing that today.
Right.
They have not presented a plan that I look at and I go, oh, that makes sense.
Right.
That's how they'll do that in 10 years.
Right.
You know, space is a lot harder. It does not advance as fast as your cell phone. It just doesn't.
Yeah.
So that's my thing with the Mars One. I would love to be wrong and for them to succeed because it puts humans on Mars, and I think that's very important. I just think that I think they're technologists and TV producers and not aerospace engineers. Anyhow, did that answer your question? Did I soapbox that again? I had lost my soapbox last week. I wasn't sure where I put it. I think I found it, and I'm using it a lot more. I'm overcompensating this week.
It's okay. No, I think it's fine. But that's the part that I feel like we hadn't ever really. I mean, we sort of went over, but no, I think it was good. I'm sure everyone's going to let us know what they think as well, because that's what our audience does.
Doug Ellison in the chat room does bring up a valid point. Inspiration Mars is infinitely more technically achievable, but similarly pretty thin on science. But, you know, the thing with Inspiration Mars, it also difficult, because I don't believe we have any craft. There is no spacecraft that can bring a human to Mars, so far as I know.
Right.
And safely return them.
Right.
Not one. So, I mean, maybe they're using Soyuz. I don't remember Inspiration Mars. Maybe they're using Soyuz, but I didn't think it was rated for a Martian re-entry.
Well, and ironically, this has so much to do with our main topic of destination versus infrastructure.
There is zero infrastructure for it, but now we've got a destination, but there's no infrastructure for it.
Right.
I mean, you know, I could be mistaken. So I actually would need to look that up. So don't take my word for that. I don't know. But okay, let's just say that Inspiration Mars does do the Apollo 8, the figure 8 style around Mars. Right. So they send a human up, you go around Mars, you come back. That, I think, would inspire a lot of people. It'd be very, very cool. So it's even if there's no science, it's inspirational. And now at least we've got the technology to get to Mars. You can't land on Mars yet, but you're there and you can see it. And even the simple act of having a human take pictures out the window, or even having live, or not live, but just recorded.
selfie.
A Mars selfie will be pretty fantastic. It will be. It just will be.
We totally geek out over the rover selfies. Right?
Yeah.
Rover selfies, or like, hey guys, this is my wheel.
It'd be busted. We can cover that.
It's so cool though. It's still so cool.
I would love to be that person who's like, bing, Instagrammed filter.
You don't know how to do selfies though.
I know that's follow me on Facebook if you want to understand. All right, last one for this particular show. This one comes from Cresshead. It says, I hope you expand your program coverage to include stuff outside of the USA, such as China, soft landing on the moon with their new rover. They have a new space station too, ESA, Russia, plus others in Japan and India. I brought that up because we actually do cover international space, and I hereby challenge the international community. The reason we cover U.S. space travel is because the U.S. does more than pretty much the rest of the world combined. Now, China is slowly starting to catch up, but when the rest of the world does stuff, we do bring it up on Spacevidcast. And if you would like us to cover it, go do cool things in space, and we will absolutely cover it. But there was an infographic we showed where if you take the rest of the world's non-military space program, combine all of it, it still doesn't equal just NASA's budget.
A little disturbing.
That's the cold, harsh reality of it. I'm not saying U.S. is better or worse. I'm saying go do cool things. Copenhagen suborbitals, freaking cool stuff. We've covered Copenhagen. It was awesome. China was doing cool stuff on the moon. Brought them up on this show. They've got their Tiangong-1. And Tiangong is the space station, right? Yeah. Covered that on the show. We absolutely cover these things. We just do more of it. Do more awesome, cool things, international community. It doesn't just have to be the U.S. Well, it can be anyone.
And you said NASA's budget, and that's not even considering at all anyone else, such as Orbital, Maston, SpaceX, Virgin, all of those other American companies that are also doing some really kick-ass stuff in space.
All right, that's our show for this week. Leave your comments. I think I want you to leave your comments on YouTube. Remember, patreon.com/spacevidcast. It helps us a lot. If you like these shows, we'll bring them to you as often as we can, and it really does help us produce really cool shows. I want to get more cameras from more angles here. I want to put more stuff in the control room. There are some pretty cool stretch goals, like if we reach 10,000. Look, I realize it's unrealistic, but dream big or go home, right? So 10,000 per episode, which would be about 40,000 per month, which is an insane amount of money for a show like this. But how cool would that be? We would build our own studio space. We would bring in live audiences. We would fly around the country bringing you, like the Morpheus thing, if we were able and allowed, we just go cover it live for you. How cool would that be? So let's try to get there. Let's make science, space, technology, engineering, let's make those the things that are really pushing forward. And I hope you guys enjoy this show. I hope that you think it's worth $1 per episode, or maybe a couple bucks per month. I hope that you enjoy it that much. If not, that's okay. You can still enjoy the show. Just leave your comments, and thank you guys so much for watching. Sadly, we will not be here next week. This is where Patreon comes in, right? You will not be paying for a show next week, because there will not be a show next week. Carrie Ann and I are taking our anniversary trip, which we do once per year, and I'm excited to go. We're going to be departing shortly, so thank you guys so much for watching, and we'll see you in 2 weeks.